morning, Cali. Today we have clear skies with a chance of earthquakes? Is that right? Oh, yeah. Yeah, you heard that right. Last night, Ferndale experienced an earthquake. Why don't we go ahead and check in on a reporter who is in Ferndale right now.
Hey, here in Ferndale, we are still alive. Some trees did fall, but I think everyone's okay. Isn't that right?
Yep. Well, a really big tree fell on our house, and I got really scared.
Well, luckily, this household knew a thing or two about earthquakes. Isn't that right?
Yeah, my grandpa knows a lot about earthquakes. He knows this much about earthquakes. He's very smart.
Yeah, seismologists, they use the Richter scale to determine how big an earthquake is. I remember my old friend Charlie Richter, back in the day in 35, he went to CIT, some school like that in California. He created the Richter scale that determines how big an earthquake was. I miss old Charlie boy.
Okay, well, there you have it, folks. Back to you, Delaney.
Thank you, X. It is good to hear that everyone is safe and that no one suffered any injuries. In light of the recent earthquake, I've invited Rose, who is a seismologist at CIT. So what exactly is your job?
Well, first off, I'd like to thank you for inviting me onto the show and talk more about seismologists. My name is Rose, like she said, and I graduated from CIT. Seismologists study earthquakes and use a seismograph to determine where an earthquake is, and they find out the magnitude and intensity of an earthquake.
So how does all of that really work?
Well, we use a machine called a seismograph. It's an instrument that records the force and duration of earthquakes amongst other details. The first seismograph was invented around 132 CE by a Chinese scientist named Chang He. From this, it has evolved into the magnificent piece of technology it is today.
Oh, wow, that's really interesting.
But that's not all. A seismograph is a device used to detect and record seismic waves. However, that isn't what you normally hear when you think of an earthquake. Most people know that the 9.1 earthquake that hit Japan a few years ago, the number that most people know is part of the Richter scale. The Richter scale is used to rate the magnitude of an earthquake, or basically the amount of energy released during an earthquake. It was made to determine the magnitude of earthquakes by assigning the earthquake a number, allowing earthquakes intensities to be compared to others. Intensity means how much the earth is shaking at a certain place. The Richter scale determines magnitude and intensity in units called local magnitude, ML, aka Richter magnitude. Some other units are the surface wave magnitude, MS, body wave magnitude, MB, and the moment magnitude, MW. Although the Richter scale is commonly used, the moment magnitude scale replaced it in 1979. The moment magnitude scale was determined more accurate, which led to this replacement even though the Richter scale is still commonly used.
Thank you, Rose. That was very informative. Now we will have a short commercial break.
Look at these, bro. It'll be so cool. Look, I got a hoodless hoodie, limited edition, and I just got a normal one. Like, who doesn't want a hoodie? That would be so cool, bro.
Hoodies are just... And now we're back. Thanks for waiting, folks. Let's continue to look at the damage that yesterday's earthquake has caused. After yesterday's earthquake, many power lines have been cut in areas surrounding the quake. Ferndale, where the epicenter of the earthquake was, received the most damage. Fortunately, no one was injured. According to this map, has 10 different places where earthquakes have hit in recent years. Each city has a magnitude of what the earthquake was. One of the highest ones was in Ridgecrest, and it had a magnitude of 7.1. That happened on July 5th, 2019. There's also been some low ones, like Westmoreland, and their magnitude was 4.9. That happened on September 30th, 2020. One in Westwood had a magnitude of 4.4. That happened March 17th, 2014, and its intensity was 25,118.86. That's all, but the increasing number of earthquakes have caused many seismologists to question why they are happening. Back to you, Delaney. Indeed, I have also noticed a growing amount of earthquakes. That's really weird. I've invited Mia to talk about catastrophic earthquakes that have happened.
Throughout history, there have been many catastrophic earthquakes around the globe. Today,
I'm going to talk to you about these quakes and how we can determine their magnitude and intensity using a formula. This table shows a list of earthquakes throughout history, missing their magnitudes and intensities. Using a logarithmic equation, I can input an intensity or magnitude to get the other. For example, the intensity of the San Francisco earthquake can be solved with the equation 10 to the 7.8 power, which should give its intensity. The same thing can be done to find a magnitude. The 2015 earthquake in Chile had an intensity of 199,526,231.5. To find the magnitude, you would do a log base 10, 199,526,231.5 minus log base 10 of 1. This would give you 8.3, or the magnitude of the earthquake. After finishing the table using the formulas, I concluded that although the Japan 2011 earthquake had the highest magnitude and intensity, the Haiti earthquake in 2010 had the most casualties.
Thank you, Mia. Now we're going to go to Professor Snape, who will talk about how earthquakes relate to math.
Hello, I am Professor Snape, and I'm going to be explaining the different equations to get intensity and magnitude of an earthquake. So, the first equation right here is log with a base of 10, I over I0 equals m, and that's how you find the magnitude of an earthquake with the intensity of the earthquake. The next equation is 10 to the m equals I, which is how you find the intensity of an earthquake using their magnitude. The next equation, log 10, intensity of the first earthquake over the intensity of the second earthquake equals the magnitude of the first earthquake minus the magnitude of the second earthquake. And this equation shows how to compare the different magnitudes of two different earthquakes. Now, as you can see down here, m equals magnitude, I equals intensity, I to the 0 equals the intensity of an earthquake with a magnitude of 0, which has an intensity of 1. And this is called a threshold earthquake, or an earthquake that you can barely feel with a little rumble in the ground. Now I'm going to show you the difference between the intensities of an earthquake with a magnitude of 6.5 and an earthquake with a magnitude of 3.2. So first, I would set up the equation, which is log to the base of 10, I1 over I2, which is the intensity of the first earthquake over the intensity of the second earthquake, equals 6.5 minus 3.2. So the first thing I would do is subtract the numbers right here, which would give you 3.3, and then I will just write out the rest of the equation on this side. Now that I have that, I will set it up into exponential form. So I will take 10, and I will put it to the 33rd power equals I1 over I2. So 10 to the 3.3 power is 1,995.26, and that will equal I1 over I2. So the difference in intensities between the magnitude of an earthquake of 6.5 and an earthquake with a magnitude of 3.2 is 1,995.26. As you know, the Richter scale compares the magnitudes of different earthquakes. And the Richter scale is a logarithmic equation because the intensity of an earthquake equals 10 to the exponent of the magnitude of an earthquake. This means that the earthquake will increase logarithmically as the magnitude increases. This is also shown in the image.
Well, that is a wrap, guys. Thank you so much for watching, and we'll see you next time on Channel 13.